Good afternoon, everyone, and welcome to the RATSBOF, Remote Attestation Procedures. My name is Roman Danilou, and I'm co-chairing with
Nancy Cam-Winget.
So we have all sorts of kind of materials prepared for you. One of the things we're going to talk about, if we get there to the end, is some charter text, and that's the link that will get you there if you haven't found it yet on the mailing list. Of course, this is an IETF meeting, so the note well applies. Please make note of the text there. If you have questions, by all means, ask. We have some administrative things, of course, to cover first. The blue sheets have been handed out, so they're going around. We need volunteers for JabberScribe and note-taking. We would immensely appreciate it.
We cannot start the meeting until we have people to help volunteer, so please.
So we have Frank.
So Frank, note taker.
And do we have anyone jabber? You can jabber. Thank you, Michael. Yeah, I think one's enough. Okay, perfect. So we have an agenda here that we'll bash in a second. First, we wanted to just explain what the layout is and the thinking. We wanted to first have a little bit of an introduction about the problem statement we want to talk about, and then talk about some relevant work. After we do that, we have a block of open mic time to discuss the problem statement. After that block of time related to the problem statement, we're then going to talk about potentially starting point drafts for some of that work. And then after that, we have another block of time to, respond to that or respond to, anything you've kind of heard so far. And, depending on how that conversation goes, we may dive into the specifics of kind of the chartering, or we may be still working to polish what the scope might be. Would anyone like to bash this agenda? Hearing no, we'll proceed forward. Just to introduce to you from the language from the charter, we're going to talk a lot more about this. The whole intent of RATS is about remote attestation and providing a means for a relying party to better understand the other half of its conversation, to understand with whom it's communicating and getting various kind of statements, claims with high confidence about what that system looks like. And we'll talk a lot more about that. If you've looked at the charter, notionally 5 things have been tossed out that we could be working on, and this is all open to discussion. I can't iterate that enough. I just lay this out for you to understand why you're going to be hearing kind of the subsequent talks. The charter talks about things like, we need to lay out terminology and architecture for this space. It lays out the need for an information and data model and a set of protocols to convey that information. And so the drafts you see listed there are potential starting points for some of that work, assuming that's the work that we wanted to take on. So that orients the drafts that are on the agenda. And because this is a BOF, what we're looking to answer are those questions up there. So I tossed them up, not that we're going to talk about them now, but towards the end of the BOF, these are the kinds of questions we're going to want to answer. Related to, do we understand really what we're working on? Is the IETF the right place to work on it? And what classes of individuals would want to work on what classes of the problem, whether it's create those drafts or review those drafts. So with that, we're going to get started with the agenda. First up is we're going to have Henk and Ned talk to us about the problem statement. And again, framing the agenda, what we would ask is, let Henk and Ned get through their material, then let Eric and Hannes get through their material. Please only ask clarifying questions. And so this will be a block of about a half hour just laying out what the thinking is. And then we have ample time then to discuss kind of what you heard there. So clarifying kind of questions, and then there'll be all sorts of time for open mic. So Henk and Ned, we invite you up. Hit escape.
There's a few adjustments here. This is not the current slides. that looks better. Hi, I'm Henk. I'm one of the proponents, what a few people would like to say, the lead proponents of this Birds of a Feather meeting, which is a second meeting, if you count the Barboff in Montreal, which we had in a room in Montreal, unfortunately, because we wanted to have more remote attendees present. So this is a collaborated effort. As you can see, there are 4 highlighted proponents, myself, of course, and then there's Intel, there's NET, there's General Electric's Monty Weissman, who unfortunately cannot be here today. He would attend remotely, but has a personal issue here, so he can take care of. And there's Eric Voigt from Cisco. Next slide, please. Oh, do I have a, oh, I have it. So in order to start where the problem actually lies, there's this trend to say 35 years ago something was, and today it isn't. This graph tells you that there was the assumption of an attacker model 35 years ago that the channel between hosts is under the control of an attacker, and that the host basically is not. So as you can see that today, this converged. We have conversions most everywhere, and this time the trust that hosts and channels are not under the control of an attacker is basically gone. We assume both are always potentially under the control of an attacker. This is the current trend. Forward should do forward, but it doesn't. Thank you. So the problem, and the problem is there's the desire to understand the host characteristics now, because the internet is communication between peers, and to prevent communication between peers of compromised integrity. Sometimes I do not want to tell a peer that is compromised, confidential, private, or some other relevant information. And assertions about this integrity of what a host characteristics cannot be assured with software solutions alone. We have that. We have a posture assessment procedure that is called network endpoint assessment. It has agents on the clients and on hosts and on servers, on the peers, and is aggregated this posture information and is trying to consolidate it, correlate it, and give you a bigger picture about the state of your system, the network, the topology. But what you actually need is assertions about the characteristics about the peers that is anchored in some hardware root of trust, and I will go more into that. And you need appropriate means to convey this information between different parties that do these remote attestation procedures. And not all of these network protocols have the same purpose and are used in the same way, but they always have to do it in a timely and secure fashion. Next slide, please. I don't know why this is not next sliding. So I'm unpacking some terms here. I was using host characteristics, but if I say that, what I mean is a system component that's defined by RFC 4949. It's well defined, so they can be physical, they can be virtual, they can be nested. It takes into account the fact, although it's a rather old glossary, that hosts are rather complicated things. Probably they are aggregated things, and probably they're more complex than you think. They can even be systems, like 120 hosts that are hidden in a single thing that you perceive. It's a pizza box. Also, I want to unpack the term host characteristics. I already mentioned assertions. And assertions are statements about something that are not accompanied with a statement of validity. So again, we want to trust something here, want to know it's true, and the old definitions basically don't have it with us. Next slide, please. So we use roots of trust. These are hidden. Sometimes you don't even know that you have some. Some are implemented in software, some are implemented in hardware. They're all providing primitives that you trust, and I could say this figuratively, blindly, because they always behave in an expected manner, and they are never, and the misbehavior of them is never detected. So they're axiomatically trusted. And that is a concept introduced quite a while ago. And NIST has a publication about it. And as discussion showed inside proponents and other bigger groups like the last Barb office, basically everything can be a root of trust. Your notebook could be. It's rather unlikely that it is, because again, it could be under the control of an attacker. So it depends on scope, capabilities, and applications. Like a light bulb probably is never as trustworthy as something that is FIPS approved and in a black box of an aviating machine, a plane. So trusting a root of trust is a decision you make. It's a management decision, and there are sometimes well-founded bases to make this decision, to trust something in the nodes of the internet, to assume they're trustworthy. And sometimes you just realize, okay, it's just a normal host. I can also trust that, but it is a different level of insurance, a different level of confidence. Next slide, established here. So always I was talking about we have to convey this information. So if you have peers that want to talk to each other, apparently at some point you have to establish that, yeah, trustworthiness exists with your communication partner, with your peer. And at some point, probably before you expose vital information or before you expose information that basically could collapse your topology on a control plane level, if you expose it because it's lied, it's false, and it's falsified, you need a way to include this remote attestation procedures in existing network protocols or create entirely new ones to address the needs that are actually defined and that will be defined in greater detail in this working group. And also I wanted to go to the message formats because that's always a big discussion. Often you hear ASN1 never again. And sometimes you hear, yeah, for example, there. And sometimes you hear the bickering about has to be human readable or is very compact. Now, how you structure it. So this is a detail to the problem, but it's a vital detail because the message format as well as the network protocols are the basis for the interoperability of all that stuff. And there are some solutions out there that address this problem, but they, first of all, never heard the term interoperability, I think. And also they are very problem specific. And that is why we're here in the IETF. We want to have semantic interoperability, especially about the things we want to prove that are relevant about integrity. And we want to have well-defined, easy to parse, IoT friendly, and even super complex safety critical system complex relevant and appropriate message formats and solutions. So some of the requirements we're going to address are freshness. So everything about integrity you know about a peer, a host, or a system component in the end that is a year old and can be replayed. It's a very simple example. It's of no use. It's another kind of being attacked. We have to ensure the integrity, confidentiality, and of course, there are privacy concerns to this. So we are talking about identities a lot and how they have been creatively used in the last 20, 30 years. And there's always some privacy concerns associated with that. So everything we do here has to be vetted at least once thoroughly with respect to what happens if we not use this in security automations or the IoT. What happens if we're doing this with financial transactions, system health, and humans again. So that's important. So to give you a, next slide, tiny impression of how this was looking like the last 15 years, is that you have a component that's on the right side, it's a verifier, that knows all the stuff, how it should be. Let's call it a role or a service. Typically, it's a verification service. And this service challenges a newcomer. Tell me about you. And this is a challenge response handshake. Freshness here, you can see there's a nonce. So the nonce included in the challenge is returned with a response. So you know that at least this answer is created in a timely fashion. But you have to do a lot of entangling of root of trusts, a lot of cryptographic procedures in order to prove in the end, oh no, that is actually the worst term I could have used, in order to provide evidence back to the verifier that can be appraised. And based on that evidence, you can make a decision. Am I trusting this? And what is the level of confidence in my trust here? Is it a notebook with no proof of root of trust, no endorsements of any of its components? Or is it rather safety critical systems in the military system? There's a big spectrum here. And health systems and financial systems and even systems that are transitioning to the internet because they didn't had one and a significant scope before, rely on these kinds of root of trust because they will be attacked by something that is state of the art today by introducing something other people had for the last 30 years. So now we'll give the next slide to Ned Smith because he will tell you about the ugly truth that is not a simplified slide here, but the things that are there, and some things we cannot address at once. So we will have phasing in this work. We will do it step by step, because if we would try to solve it all at once, it seems a little bit unstructured.
Okay, so here's an example of remote attestation that shows a little more of the detail. So you can see here, there's actually more than three parties in this example. So we have the device, which is the attester, and then you have the relying party or the verifier. But you also have the manufacturer who's going to play a role in this. And in the sense that we described earlier, that part of the challenge was that we're combining the communication components and the device components, but we're not trusting them at all. We really have to go back into the manufacturing space in order to be able to derive or establish what the roots of trust are. And to some extent, we're relying on the manufacturers being trustworthy manufacturers. So there's the notion of the device manufacturer who's going to essentially issue some sort of a certificate, and that's going to provide, that certificate could provide a set of assertions about the device. And then in this example, we're showing a subcomponent, which is a root of trust, that also has some assertions that are made by a root of trust manufacturer. So you sort of start to see the complexity of supply chain, where all the parts that make up the system maybe don't come together at different times, and there's potential for sort of different sets of assertions about the different parts at different phases in the supply chain as things come together into a final product. And then in the context of the root of trust, there's some expectations in terms of what it can accomplish. But in particular, the main components here, there's some sort of attestation key that we would expect is being protected by the root of trust. There's some measurements, which is essentially, the term measurement refers to some ability to compute a hash of some relevant component of the system. For example, its firmware. And then there's some component in there which is doing the evidence creation or collection, assembling it in a certain way, and then signing it and creating this thing called the remote attestation. Think of that as the message that gets passed to the verifier. And then on the verifier side, there's potentially multiple components over there. There's something that's going to verify the signature, and then extract out of that a set of assertions, and those assertions are then passed to something that's going to evaluate risk based on the application of how these assertions might affect affect risk. Okay.
Just for the sake of thinking, we have basically 5 minutes left for the slot now. I wanted to illustrate, is this point I think about? Yeah. So we have a very important part on this slide. That is essentially, if you pull it a little bit into the boxes, our first phase. We have key material. We have derivation functions for this key material. And we have a lot of, and this is very important, the independent parties that add or detract from trust in supply chain management. But we cannot focus on it all at the beginning. So our focus will lie here. That is very important to highlight, which does not mean that we will never come to points like how does a suitable inter-supply chain provisioning mechanism and trust system works. How is a root of trust able to assess locally what is trustworthy or not. Sometimes you just don't have this interconnect here. So how is it deployed with protection profiles? How is it verified? So we are talking about verification service before. If you think about, for example, software component integrity, your notebook has like, I don't know, 250,000 software components. I think a light bulb would be a little bit overwhelmed being a verifier. So this has to be offloaded. This is a burden. This one just wants to have a interesting and tangible information about the trustworthiness. But maybe it has to be detached. So there will be roles. But now I'm going into details already. But I really wanted to highlight we fragment the problem. And we're starting with what we can do best with the network protocols and the message formats and specific use case that will be shown today in demos and more use case related slides in the next slot. And I think that is very important to highlight. Sorry for interrupting. Yeah, so we actually have some time left. Is there any uncertainty about the problem we want to address here? Is it somehow too big, too small?
No, Hank. That's not
Oh, we
what
don't
we're
have
doing.
the discussion yet. I'm sorry. We have the discussion later.
So-
The agenda was later. Sorry.
Clarifying questions now.
Clarifying
only,
questions.
And then really to
I'm
re-explain
sorry.
the agenda, clarifying questions here, then we're going to have 2 5-minute talks
Yeah.
about other kind of related work, and then we're going to open up the mics for whatever discussion we want to have on the problem statement.
Sounds way more feasible.
So-
It's the agenda, right? Yeah.
So clarifying questions on what we just heard here.
Maybe I would do the complement of the question. Who didn't get it at all and isn't interested?
Hank, we have to scope this. So,
Is this good?
no,
Clarifying?
we're gonna.
Oh,
we're
I'm
gonna hold
sorry
that to
again.
the discussion.
I'm so sorry. Yeah, I'm too early for this.
Yes. Okay, so I see no one coming up to mind for clarifying questions, so we are now going to do 2 very short presentations
And who's next?
on related work. Eric is going to be next.
Okay, no, not that.
So if you could click on that. All right, Eric, if you could get in the queue, if you're going to be ready to go to present. Eric is remote, so Eric, we need you to get into the queue so we can turn it over to you.
Can Eric hear us?
Okay, so Eric, why don't you work on the comms? Maybe we'll flip. If you can go to the next tab. Hannes, if you wouldn't mind going.
Oh,
All right, Eric, you're in the queue. Excellent. We're flipping back to your slides. The floor is yours.
So, sorry for giving you guys trouble. I just had to find the Q button. I was clicking the wrong button. Can you see me? Can you hear me?
We can. The floor is yours.
All right. Thanks, guys. Greetings from the East Coast of the USA, where it's darker and colder than the 35 degrees you had during lunch. I'm sorry I couldn't be there today, and maybe I can do better clicking my in the queue buttons, but thanks for letting me talk remotely. And I'm going to be talking about rats in routers and switches, which of course is why I called my presentation Compromised Trustworthy Visibility in Working Systems. I probably should have just called it Rats in Routers and Switches. So, you know, that's where we're at. I can't see the slides, so I'm going to just say go to the second slide or the agenda slide.
You're there, Eric.
All right. Honestly, this slide and the Compromised Trustworthy Visibility is a slightly awkward title. I initially just called this Compromised Visibility. However, compromises are often visible. The real trouble is knowing where to look. And being able to trust the visibility of what's going on is the hard problem. And the reason, you know, talking to the others and the proponents is what they wanted me to talk now is they just wanted me to show and prove that this is something that we care about for routers and switches. And this is something we've been doing for a little while now, a couple of years. So my presentation is going to be pretty easy. I just have to prove that RATS exists and is relevant to routers and switches, and explain the scope of the problem domain as seen by a networking vendor. So I'm just going to sort of talk about the scope of the problem as we see it, and give something called not demo. And why is it not demo? Well, basically, I passed a demo recording to our chairs, and basically we didn't want to take time to go through it all. So I just took a couple screenshots from it. And so I'm going to show a couple just slides of the demo that I was going to give. Hopefully at some point in the future, I'll give a more full demo. All right, next slide. Now, there's a few things that make routers and switches slightly different than PCs and phones and IoT devices. Basically, routers and switches come in big and small. They're not really monolithic devices. They have lots of components in them. They don't boot very often. Nevertheless, they really do share quite a few characteristics with PCs and other attested devices. And what I'm going to really talk about now is some of the things that bring them together. When you're trying to attest a router and switch, you need to have several bits of information that you can look at and see if it's compromised or not. For example, is there a known good value? Did your software boot something that is a known hash that you expected? Is there an imprint value? For example, did you look at a section of memory after it booted and has it changed? Should that memory have changed? Or did some event occur? In footprints for routers, sometimes you're looking for an event like an event from a log, and did this event log show that you have a known virus? So basically, attesting switches and routers mean that you're comparing against event occurrences, imprint values, and known good values. And these are really the items that are put together for a good attesting system for switches and routers. Next slide. Now, in looking at switches and routers, there are some differences from PCs and IoT. The biggest part really is the modularity of the systems and the size of the systems. In implementations that we see on the vendor side, we can break that down into various categories, such as what are the secure boot items, what is the software, what are the logs, the hardware, how many chips do we have to track, what are the identity of chips, and the configuration. Do you have an expected configuration? Has it changed? These, again, are things that are showing that this is more than just boot time integrity or something you'd see like an IMA. There are things that make checking out routers and switches a little bit easier as well. It's not just the complexity of the monolithic system. You also have lots of keys or other items that you have to track in a system which is fairly predictable versus random software that would be added potentially in a PC or a IoT or phone device. And because of this, because we have a system which is more locked down, you typically have less stuff that you have to check out from unknown software running on the device. Now, on the other side, we do have to check a number of things that are a little bit more complicated, or at least from my perspective, from smaller devices. And these are things like, do you want to attest to the identity based on the adjacencies of the routers and switches next to you? Do you want to go ahead and look at your neighbors? Do you want to attest for configuration of, let's say, access control lists? All these things could be relevant to routers and switches. And the big thing we have to worry about, especially with routers and switches, is the big word asynchronous at the bottom of the slide. We care about things that change. We care about things that change, and we have to get alerts on as they're happening. This does make stuff a little bit different in our environment. All right, next slide. You're going to see, a couple of the screenshots. If you look at this slide, at least you're going to see what I just talked about with the software, the hardware, the router going against 6 particular devices. And you see little circles at the top. The circle on the top left with the red shows us finding potential issues with 4 out of 6 devices that we're monitoring. And those devices, again, might have hardware issues or software issues. And really what you're just doing is seeing a breakdown of those routers against those known attack types. If I were to choose one of the routers or one of the attacks of what's going on, we'll go to my last screenshot, so slide 6. And in that screenshot, you'll see things that should be pretty familiar to people who are comfortable with remote attestation, where at the very bottom of the slide, you'll see a boot status of failed with an integrity signature and a nonce that was provided from that router. And the fact that that boot signature, the file, boot file has failed, just lets you highlight that you probably have something going on with your router and switch that you have to take some remedial action on. And for anybody who wants to look more and learn more about what's possible here, I do have a link at the bottom of the slide. But as I mentioned, my first premise of what I wanted to do is fairly short. I just wanted to prove that it was relevant to routers and switches, and then give you a quick idea, a demo of what at least the state of art from my perspective is. And that's it from my side.
Perfect. Thanks, Eric. We have some folks coming up to the mic for asking only clarifying questions.
Okay, Frank Xia, Huawei. I have two questions. First is, can we go to your the fourth stage? Oh, sorry, the 4th page. Okay. In this page, you have listed a lot of information that we can collect to do the remote attestation. So my question is, I see some of them maybe it's not so related to the integrated track. For example, some configuration or some interface state. So are you going to just collect the raw information, or you want to still calculate the hash or the integrated value based on all those informations and do the integrated track? So,
Okay. I don't know if that's a clarifying question, but I'll do my best.
Yeah, I was going to say,
It's a clarify-
can we defer that for the open mic? This is really more for clarifying.
yeah, clarify.
Okay, so this is not a clarifying question.
No, I just think that the attribute list here may mislead us to some certain, because from my understanding, the remote attestation is collect the integrated information from the device, but some of this information may be not related to the integrated.
That might be the case. Frank.
Comments,
We
yeah.
can clarify that
Okay.
in the open discussion.
Oh, okay.
Thank you.
Eric, not mine. It might be in the same vein, but in your existing system, Eric, do you get a yes, no, this is trustworthy as opposed to not? Or are some of these things sort of gray areas where something changed, so it's really about sort of different severity?
There are gray areas. Often we'll get a change and then we'll say, is this okay? So we do have different levels of alert that are not this is bad, but it's, is this good? And then people can go ahead and click and say, yeah, this is good. So we do have different levels like that.
Alyssa Cooper, feel free to tell me this is not clarifying. I'm not sure if it is or not, but I was just wondering, Eric, if you could explain your need for interop in the case of the router and switch. Like what is the use case where both ends wouldn't be essentially owned by the same party?
All right. We certainly care about that as a switch and router vendor. I know that there are a number of boxes out there which are looking at managing the routers and switches. So having an understanding of what the kind of information that you'd provide up and how to know how to attest it is certainly something we care a lot about. In the application side, because you're pulling a whole bit of different information from the software, from the router, the configuration, even knowing what you're attesting and why, and that list of things that Frank pointed out earlier, you're going to be pointing to lots of possible information which could be identifying the health of the system. And that's why I erred on the larger size of things that we might want to attest to, just to support what was people were talking about with EAT earlier, in having a standard set of parameters that you might send up and want to attest from. That's one of the reasons I use the larger, more targeted set of future definitions, as I thought it matched to the charter that was being proposed.
So I'm cutting the line.
Thanks.
Thanks. Please, if you could keep it brief, because
Yeah,
I want to get
sure.
to the point where we
Okay.
can open the mic for
Yeah,
broader
So
conversation.
this is Hank from the floor, and yes, of course, this is not all correlated, of course, but it is based on if you start with remote attestation from the very beginning, and you have the high confidence this is a trustworthy system, and then the evidence with high confidence tells you some of things of this quality change, then the concern is way higher, because everything has been actually healthy before. It's not just you got data that was false and now you got other data that might be false. So the difference here is if something changes in this timeline, compatible with remote attestation procedures, it is way more of interest if we wouldn't use them.
Thanks. And the last clarifying question.
It's actually to add to the answer. Shweta from Cisco. To answer Alisa's question and add to Eric. It's for the same reason that we have common data models for evaluating operational state. We want the same, for the same reason we want it to be interoperable, because attester and the attestees could come from different vendors, and you don't want to do attestation based on the vendor the attestee is coming from.
Yes, what she
Thank
said.
Thank you for that. Okay. Thank you, Eric. Hannes is up.
And I try to really keep it to 5 minutes. So I have two examples. One is from OWASP. OWASP works on delegated authorization, and we have various different deployments, and you are using them pretty much every day. One of them is a native app deployment where you actually, the OWASP client resides on a mobile phone, on a tablet, on your laptop, wherever, and it's the same code distributed to all those, so that you have one app developed that is sent to all the mobile phones or tablets, for example. And we are seeing OWASP being used in sort of high-value transaction banking, medical applications, payments, electronic signatures, and so on. And so now, today, we don't have a standardized way to communicate from that app to the authorization server or to the relying party on where this app is actually running on. What type of hardware is it running on? What type of software is it running on? The servers don't know. Wouldn't it be great if we actually have that capability? And there's actually a document that a few folks in the working group, in the OWASP working group, put together called Device Posture, where they tried to come up with some of that information. And obviously there needs to be some security protection around it. That's one of the cases that we are looking into. Next one. The Internet of Things case is probably even simpler. I took two boards with me. Both are like this, a white and red. You won't see much more than that because these things are small, even though it's a developer board. Both are ARM Cortex-M microcontrollers. This is a new generation, our latest generation called V8M. This one is the earlier generation, V7M. And if you're not working in the IoT space, that means exactly 0 to you. But on the server side, if you have devices that are connecting to your servers, or for example, to your home appliances, you may care about knowing which device connects to you, what hardware capabilities it has, because this one, the red board, actually has trust zone capabilities, which you're also using on your mobile phone, and the other one, the white board, doesn't. And so that's good to know. You also may want to know, like, is that functionality really used? Even if it has some hardware security feature, is it actually used? Because obviously the software matters as well. It may just completely ignore it. Or the whole thing may run in a QEMU image, and there may be no hardware, like IoT hardware at all. And that's something we would like to communicate securely, obviously, and having a standardized mechanism to do so. That's essentially the story.
Thank you for that. Are there any clarifying questions for Hannes? Okay, so I appreciate everyone's patience. The floor is now opened. We have a half-hour slot to discuss the problem that you've heard.
Oh, my.
Again,
I appreciate everyone's patience.
Oh,
Getting here.
okay, Frank
Okay,
Sha.
so Frank,
okay,
please.
I think I can ask more question now. Okay, we have seen at least the two use cases. One is from the network device, and another is about IoT. So I'm wondering if we include so many use cases in this working group, so can we produce a single protocol for so many different use cases? I think that maybe there are different requirements and different design for them. So that's a consensus. Maybe we can produce one. And the second concern is about if we're talking about a network device, remote attestation protocol. I think maybe we also in this working group, maybe we should also consider the backward compatibility problem, because if we want to because there are already a lot of devices is deployed in the field in the network. So if we want to actually, at least from our side, if we have this protocol, we want this protocol to be very easily deployed to the current existing devices, and we can enhance our security in our network. So, but I don't see any consensus about this currently. Maybe we later we can consider this.
So just to clarify, Frank, with your first point, the observation you're making is that there's a lot of different use cases, network devices, IoT, PC, and the question is, can we really get to the point of having one, one kind of format or kind of one protocol for those different use cases?
Yes, actually, I remember in last IETF meeting, we proposed an individual draft about the NFV environment use case about the remote attestation, but unfortunately, we don't present in this time. But so we have IoT, we have a network device, we have NFV, so a lot, so many use cases.
Yeah. Thanks. Dave?
Dave Taylor. From Microsoft, and we do things like Xbox and Azure Sphere and things to do attestation with hardware roots of trust. We deal with SGX and Trust Zone and so on. And so I personally have at least some familiarity in this space. I may not be as expert as some other people, but I have some familiarity in this space. And so I wanted to talk about the proposed remote attestation model. And you don't have to go to the slide, because with all of my familiarity, I couldn't understand that slide at all. And so I'm not going to talk about it. I'm going to talk about what I think the proposed remote attestation model ought to be. And maybe other people can tell me whether it maps to what they have in their head or if they understood that slide or whatever. There's three entities, potentially, that I think are useful. There's the entity that you want to figure out its health, like the boards that Hannes is holding up. There's the entity that it wants, that's the relying party that it wants to communicate with, that wants to tell whether that thing is healthy according to some policy. And then the third entity, which will often exist, but maybe in some implementations it doesn't, is an attestation server. That's what supplies to the device something that can hand to the relying party. Okay, that's the architecture that I understand. And there's other, more complicated instantiations where there's like multiple of them and chained ones and so on. But in the simple case, there's only three entities. Okay, and so that leaves at least two protocols. There's one protocol that says I am a device, like Hannes' red board, and when I get something that I can supply to relying parties. Yeah, this is the one I don't understand. Okay, and so I want to get that thing. I can understand pieces of this, right? And so that's where things like Alyssa's question is relevant, that says, okay, if that's the manufacturer between the device, do I actually need interoperability there? Okay, that's the right question to ask. Okay, my personal opinion is yes, but maybe other people's opinions may differ, but that is the right question to ask. And then the second thing is there's a protocol that goes between the device and a relying party. Okay, that protocol is things that device is already doing today, typically. Okay, or maybe something in the future that's not doing yet. There's plenty of other protocols that it wants to communicate with. Okay, whether that's CoAP in some IoT cases or HTTP or whatever else. Okay, and so it wants to pass this to that pass this to the relying party that it's already going to communicate with. We have a protocol they both know, and it's maybe already a standard, maybe not. Okay, and so this goes back to the question of how many different formats do we need? Right, this is the question that was asked a second ago. Okay. There's a large number of different protocols that already exist, and we're not going to reinvent all of them, right? This is the IETF. We don't reinvent every protocol in the world. We try not to boil the ocean. So what that means is that different protocols have the ability to do different things. Some of them pass, say, X509 certs. Some of them pass JSON web tokens. Some of them pass CBOR web tokens. Some of them might pass other things. Okay. That means if you want to use this as one of those and you don't want something extra complicated, that means the thing that you want to supply across there is one of those aforementioned things that you can't dictate which one it's going to be. It's the protocol that you're going to use that dictates which one it's going to be. Okay. So that means that I'm in favor, personally, of saying, yep, I want there to be a format that works with protocols that use X509 certs. Yep, I want there to be a token, right? I want there to be something that works with the protocols that pass JSON web tokens. Whatever it is that's a common mechanism I don't want to reinvent, I want to be able to get a token or a set of attestation claims that is in that format that I can supply. That's what I think the problem statement is. The end.
Got it. So to kind of,
Yeah. So to summarize in 1 or 2 sentences, Dave, you're agreeing that there is a problem. The model may not be correct in your eyes.
There is a problem, in fact,
Yes.
potentially 2 problems that I want to solve. I personally want to solve the problem of having an interoperable protocol that goes between a device that wants to be attested and an attestation server of some sort, okay? That is there to get an attestation token or whatever term you want to use. And then I want to specify or want to have standards for the token that you supply, where there's probably multiple formats because they got to be used in different protocols that already dictate different formats, whether JWT, X509, whatever it is. Okay.
Thank you.
Hi, Elliot Lear. Wow, am I glad I went after Dave. It's always a good idea to go after Dave. Just a couple of points. First of all, I think I see 2 different questions that came out of this the presentations. The first was, if I understand correctly, really I'm in a known state, and has that state changed, right? Or has somebody monkeyed with a state in a way that I can notice? And the other is, what is it that what does that state consist of? I think these are 2 separate questions. I don't know if they can be answered in one single list, one single bag of bits, if you will, Dave. In terms of how it's formatted or encoded is not my concern at the moment. It's, can you even reduce down to, is it 1 question or 2 questions that you've got there, right? Is it the state change, or is it what the state is? So that's 1 point. And the second point is that I think I agree with Dave. I also agree with Dave that this stuff is going to be transported in different ways using different trust methods, I think, in all likelihood. And so we have this exact problem actually with IoT onboarding, right? It's the exact same problem. And it'd be nice, as we're thinking about this problem, if we could also think about that problem.
Don't bring onboarding here.
I'm not bringing onboarding here, but let's think beyond just, let's not try, as Dave said, let's try not to invent too many new mechanisms. And if we can think in the same dimensions, and if there's the opportunity to capitalize on that, I would love to link the 2 a little bit, not tightly, but at least architecturally, the dimensions are similar.
okay. So to wrap that up, you would also assert there is a problem here. Your view is that there's 2 problems. When you talk about formats, there's this notion of detecting the change in state, and then what is the state itself. And you're reiterating also that in the blob of bits that characterizes one of those kind of 2 formats, there's need for flexibility on what is the transport that ships them.
Yeah, and just to you know what, let me stop there. I'll say more later.
Okay, thank you.
Tony Nadlin, Microsoft. So I don't care about the transport necessarily as Dave does, but I care about the privacy aspects of correlation, and I'm not seeing anything here that really addresses this. This is one of our biggest concerns with authentication, is the correlation of these attestations and stuff. The other thing that I'm not quite seeing here is, is probably trying to separate the protocol from the formats, right? And having the right formats, because we're having so many of these different formats that we're trying to use. And so that's our biggest concern. Also, making sure that this is has crypto agility in it, right? We've seen so many of these attestations in the cryptography that they wind up using is pretty poor. And so, yeah, and these also just seem to be towards devices. We're also interested in applications and other things beyond devices. And so that's also a concern that we have.
Okay, so thanks. So to roll up again, you believe there is kind of a problem. Your primary concern is in the format rather than the transport. Don't forget about privacy. Don't forget about agility in the transport. So, the crypto agility. Yeah.
Eric Nordmark. Yeah, I think there's several problems here. I haven't tried to count them yet, but there's clearly a core one, which is that remote attestation blob in the center, right? But there's 2 or 3 comments I want to make. One is that this picture has this device manufacturer at the top, right? And I don't think that that's necessarily desirable and flexible enough, because for 2 reasons. One is that, well, that makes that few places basically the root of all trust in the universe, or at least on this planet. And that's a very attractive target. But it's also the case that somebody who takes possession of a device, they might very well go through and do their own checks with electron microscopes, whatever, right? And they want to say, well, now this is actually mine. I have actually checked it out. I want to make this be mine from the perspective of the root of trust. And so I don't think we should hard code that that's a device manufacturer. I don't care about the mechanisms, but I think we need a bit more flexibility. We might not have to worry about that part of the picture up front if we start sort of at that bottom middle, but don't lock down on that too early. Well, I'm not going to say the onboarding problem, but in terms of the architecture, right? There's something there that is a root of trust. It might be multiple because it might be the manufacturer, it might be the owner or whatever type thing, right? And thinking about there could be more than 2. I mean, more than 1, right? The other one I think is also terminology one, which is that in many cases we talk about hardware root of trust. And I think that might lead us around also a path that's not flexible enough just from a terminology perspective. I suspect a TPM chip has some firmware on it. You can't change it, but I suspect it's there, right? And the notion that, yes, there's actually different degrees of tamper-proofness, whatever we associate with this stuff. TPM chips is one, a TPM piece of firmware running in the BIOS is a different one, right? And that sort of brings in these other things with SGX and trust zones and other ways of implementing this stuff where you have different levels of tamper-proofness built into the system. And the third one, going back to the privacy, it's very good to bring that up. I think that we need to think about that more. The notion that I will disclose all assertions to everybody that I'm going to talk to, it's not necessarily good from a privacy perspective. So having policies, thinking about how are the policies in the system that to random web server, I will provide some assertions. Maybe I'll provide more of them to the bank, however I know that, as opposed to as part of, being part of a management system where my generator is being managed by the generator manufacturer, I might provide all of the assertions, right? Because there's a higher level of trust there.
Okay, so Eric, to summarize again in 1 or 2 sentences, you are agreeing that there is a problem, but perhaps the definition of how we're approaching the root of trust may need to be more flexible or open, right? And the second one, which we've already heard about, is the privacy considerations.
Well, the root of trust might not be the device manufacturer, right? It might be multiple. The
That's
middle
what I
one
meant.
was, don't assume there's a hardware root of trust. There's a root
That's what
on
I
the
meant by
device,
the definition of how we approach the root of trust. Right. Thanks.
Max Pala, Cable Labs. Several comments, actually stole most of them. About the privacy issue, I think it's very important, and I want to stress that aspect. One of the things that you were saying, and I totally agree with it, was the fact that we need to actually tackle the problem who can access which type of assertion, because as you were saying, some assertions can expose some data that you don't want to expose to the internet tokens, for example. Others instead, in local conversation with some other hardware that you're integrating with, you might want to expose certain information. And that is something that probably is very hard to do. And might require some authorization to who can actually request a remote attestation. Not everybody can be entitled to do that. The other one is, to protect this data, we need to use some form of cryptography, and cryptography rely on trust anchors at some point. Now, in an open environment, that's a problem, right? Because you need to be able to distribute these trust anchors and to make sure that I can verify the remote attestation somehow, right? By means of cryptography. So this is probably the discussion about the protocol should be also taking consideration these aspects. How do we trust that information? How do we build a trust infrastructure that can support this kind of remote attestation? And the other thing is more about what everybody is saying. We already have a lot of remote attestation solutions. Some of them are proprietary. There's probably a lot of patents around that. And so it's probably a minefield at some point. So we have to be careful. One of the questions that I have, it was about something that was said and not said. We start with the protocol and then we look at other aspects. In my experience, most of these solutions that do remote attestation, what they actually do is a local attestation that someone can access, and there's always the problem of time of check and time of views, right? So you verify most of the time firmware, operating system, maybe the application if you're very good or very lucky, but in a multi-threaded, multi-process environment, this is very dynamic, so it cannot really be attested reliably or sufficiently, or at least I didn't see, in my experience, I didn't see any good solution about that. So maybe try to define what are we trying to attest, right? Are we trying to make a basic attestation that the device was booted in a certain way and now you're more or less okay? Or are we trying to say, this is the whole status at this time of the device, right? Those are two very different things. The second one, I think, is intractable, at least in my experience. And I would try to focus more on simpler solution, at least at the beginning, try to define the scope that way.
Thank you.
Brett Jordan. I'm really excited about this. I see this as being something that can be used in many spaces. There are going to be some challenges. There's going to be some things we're going to need to work through, and there's going to be some hard problems that we're going to have to answer, and some really hard questions. I can see this being used in some of the work that I'm bringing to the IETF through course of action and playbooks, but I also see this being used in Beyond Corp. Like when you look at Google's Beyond Corp, they are required to know everything about the end device. Well, what happens when you don't have all the knowledge about the end devices? I see that this could be a stepping stone for getting us to, a next level. And so I'm really super excited about this. I fully support it, and I will be contributing here.
Thank you for that.
Hi, this is Henk from the floor. Clarifying some of the points. So I heard, of course, we're focusing on a set of network protocols and formats. Certainly, we're doing protocols, but which is not basically, which will come later, but I want to highlight before now, the assertion semantics are the essential basis for the semantic interoperability, apparently, and those will always have a privacy annotation. So semantics of assertions can be totally uncritical in one domain, but absolutely confidential in another domain. And Suresh, Alexei was it, pushed the idea of how do you deploy all these required things consider Bluesky, consider Acme, please. This is I think that's coming from you. So, and yes, of course, there are a lot of existing protocols, but this is most certainly not phase one. But we are aware that these have to be somewhere. For example, protection profiles for local attestation. Yes, of course, we are aware of that. And yes, this is done in box. But we will not deal with how to supply them in a meaningful interoperable way today. This will always come later. If you try to solve everything at once, this will implode very hard very soon. So this was my biggest thing. And the non reinventing the wheel, of course, we have TalkBind, we have some slots where we can put stuff in. It's very important to us because that would mean a lot of bickering and work that is futile. And this is most certainly not what we intend here to do. So yeah, that's basically the biggest things I wanted to highlight. Also, to Elliot's point, you said there are two options on the left side, like questions changing, and then the other one, and then there's the third one that's going through the verifying service that can be a very big thing. That's how do you compare stuff to? How do you check that evidence is actually okay? And again, the relying party wants this gray area. Is it just, Eric was asking this, green or red or something in between? And if there's something between, you need a very relative complicated verification process, an appraisal of evidence with rather big taxonomies and semantics of assertions. Again, with respect to confidentiality and privacy. And yes, this is in our heads. It will be, parts of it will be in the charter.
Hi, Leif Johan from Sunet. So I want to talk about SEC events. It's another working group in the IETF. It's sort of, if you squint at this, it's the same architecture. The only difference is that in SEC events, it's all about data subjects and not devices. But other than that, it's the same thing, right? And I think this is going to be I think this work, if it goes forward, is going to face more or less exactly the same problems that SEC event faced, right? And that's sort of goes back to what Frank and Dave and Alyssa was talking about, namely interoperability. Where exactly does interoperability live here? And I suspect that you will only find interoperability if you narrow the scope of, to one of the various use cases, or a very small number of the various use cases that you got in this presentation. Just look at the security keys or network elements, right? And then specify metadata for those in a format specification. Because if you look at what SEC events faced, in various working groups meetings, you had discussions about what goes into the attestation. What makes a JOT a SEC event token, right? And the only thing people could agree on basically is that it contains a timestamp with a particular semantic, right? And that doesn't amount to much. So I think maybe if you were to do something of value here is to write down the architecture for like a best practice architecture for establishing an attestation platform or an attestation system, right? It's all about signatures instead of protecting the transport. Right? There are privacy considerations that go over here, but not over there. Right? All of that stuff you could write down in an architecture document, have that published in a working group document, and do nothing else. Right? And at least we could not have a repeat of these kinds of working group in a lot of domains, because I'm not entirely sure that this is valuable as a broadly scoped work in the IETF.
So to wrap up, the top line feedback is you're not sure about the difference between this and kind of SEC events, and there's lessons learned there about whether there's a more generalized solving.
Exactly. If it all amounts to turning SEC events into CBOR and relaxing the data subject constraints on SEC events, then you haven't done anything.
Ben Haydock. So I'm really happy to hear that we had several people coming up and reiterating that there's privacy considerations. Of course, we have to deal with that, and also the same statement about needing some sort of authorization checks for who do you actually send these attestation statements to, because you don't want to be some oracle that just says anybody on the internet can
push a button and I will spew all my data at them. Of course, the device is always going to have the choice to not send the attestation based on those authorization checks. Max had brought up the question of Max had brought up the question of are we trying to answer the question of is this device okay in some holistic sense? I don't think that's something that's really possible to do. I think the scope here is just going to be limited to here is some data and some cryptographic assertions that chain up to some root of trust, and the verifier has this very fuzzy risk model basically to try and make its decision on. I don't think we can try to say yes or no, this is good. And so, similarly with that verifier fuzzy risk model, the verifier can choose what roots of trust it is or is not going to trust. I think that's important to remember. And several people also spoke to the question of where is the interoperability going to be here? And I think there's potentially broad scope for interoperability. You might consider the question of, I have some intrusion detection system or some network health monitoring system on my network, and that may want to be collecting attestation information from all sorts of different things on the network that are, of course, made by different manufacturers. And so I think there's a case there where you do need the interoperability between all sorts of different devices and manufacturers.
I'm cutting the line at the people that are there so we can do the next part of the presentation. Again, there'll be plenty more time for conversation.
Tony Nadlin. One thing to bring up is there has been work going on in the W3C on verifiable claims. And so they're trying to do the data model, but they've chosen this nasty thing, JSON LD. And so that's their particular model. And a lot of cases it doesn't work for devices and things like that. But they have tried to lay out the data models. They're not looking at transport. They're just looking at the various data models for claims and attestations.
Got it. So some related work in W3C. Thank you for that. Dave.
So Dave Taylor. So I think Leaf, is that how you say it? Okay. I liked his comments. I think that helps to frame some of the privacy discussions again, because I think the privacy discussions are mostly what you send to relying parties, right? Not what you might communicate with to your attestation server. And so at least that's how I interpreted what you said, right? Yeah, right. And so for all the people that, Eric and folks that have talked about the privacy things, I take your point that says, well, there might be long discussions about what is appropriate and how do you actually decide and so on. And so I thought that was a very valuable comment. I'm just confirming it with you that that does not apply to the attestation server mechanism. No, that's the market. Right, okay, right. And so there's probably less of an issue with the privacy stuff for the protocol to get your token or whatever, although you might want to say, here's the type of entity that I'm talking to that might dictate what appears in the token that you're going to pass off, right? And so you might have some policy that's done at that level, right? So you're passing off different things to different types of entities. So if you do that, then if you can't agree on all this stuff, then maybe what goes in there as a minimal set is very small. It's the fact that it's signed by the server, okay? And that's the yes/no. Is either it's signed by the server that you trust or it's not signed by the server you trust. And if you want to be more complicated than that, then you can add in a security level or something, but then that's what gets you into the arguments that the Leaf is talking about, right? So the simplest possible model is you send off all of your data off to the server, he either gives you a token or he doesn't. And you pass that off and the relying party says, yep, it's either in policy according to that server or it's not. That's the simplest possible model. It doesn't carry anything but the timestamp and the fact that it's signed by the server. Is that a fair summary? Okay. And he says, and then it looks exactly like second event. Yeah.
Got it. All right, so thank you for all of that feedback on the problem statement. I will attempt to, on the fly, summarize what everyone has kind of told us according to some wide bins. I'm projecting kind of here. So we predominantly heard that mostly folks said, yes, there seems to be a unique and important problem, ***, with kind of a lot of caveats. We heard discussion that, clearly part of this in scope is formats. Those formats may talk about the state itself. They may talk about state changes. We may need to have some flexibility in what kind of encoding we do. We had a lot of talk about kind of architecture, I heard no one kind of pushing back on the clarity of there's three dimensions to it. There's the device, there's the relying party, and there's the attestation server. And I heard the notion of we should be using root of trust, not hardware root of trust, to provide some flexibility there. As to and the device can also be hardware or hardware applications. Yeah, thanks, Nancy. Then with regards to transport, we want to have some flexibility. We may need that in the architecture to convey that blob that I'm calling a token. We got to have crypto agility there. And then kind of in a more kind of grab bag as we think about what the solution is, we got to think about privacy in a lot of different ways. Let's prevent correlation. Let's think through who we send it to and what they can see. Some flexibility on the device, knowing what it's going to pass, and it's not a one size fits all about what it passes. And there's a lot of related work. We heard a lot about SEC events as potentially being some part of that same problem. W3C as well. And then open questions we heard mentioned a couple times where are we sure we know where we need the interoperability, and raising concern, can we really get to a single solution for all our different use cases?
Hi, Aaron Falk. I think that you're next to the last bullet, that you don't have a clear understanding of where interoperability is needed, really underlies or negates your first statement, which is that there's some agreement that there's a unique and important problem. I don't think that what I've heard in the discussion today is that there's agreement that there's a unique and important problem. I think if you can define where you need interoperability, then you'll know if you have a problem that the IETF can solve. I agree with the rest of the stuff, but I think that a useful outcome of this BOF would be if people can get some agreement on, why standardize something if you don't have an interoperability problem that you're trying to solve.
Hi, 2 points. This is Elliot again. I think I want to go back to what I thought I had said, which is I think there are two statements where I thought at least one of which was clear as to what the problem statement was, which was, do we want to be able to have a means by which to validly collect attestation information? I think Dave stated the problem statement really well, actually. And then the second one is whether you provide that in, aggregate form, as in the, has state changed, or in granular form, as in here is the state. So I thought we did cover that ground, but I don't see that well listed there. The second point I wanted to make was in terms of the architecture, I think, and where there is some flexibility, what the root of trust looks like, or the chain to that root of trust looks like, how that is anchored, I think is also an area in which we may not be able to nail one particular means down. This goes back to Eric Nordmark's point, right? Which was, does this go back to a manufacturer? Does it go to, or does it go to some local deployment? Some of that needs a little bit of work. It's not, I think it's part of the problem, not necessarily I'm going to say that there's a solution at the moment.
Okay, I'm going to cut the line in response to kind of this summary. Everyone on the line, by all means, going to proceed. We're, again, in terms of agenda, we're going to have a talk about one draft that potentially addresses some of that, and then we're going to open up the line again for all sorts of comments for whatever we want to talk about. But
hi, my name is Michael Richardson. In the Anima NetConf and 6tish group, we wound up producing this RFC 8366, which is the voucher artifact. There are some relationships between what we asserted and what you may assert. 2 years ago, we were quite convinced the voucher was a private arrangement between the manufacturer and the devices that the manufacturer manufactured. I feel like Dr. Zeus that way. But the point was that we believed that we needed to transport it across the internet, and that beyond saying this is a voucher, we had no business or care what was going to go in it. And that was great. And then suddenly we had this realization, I guess about 2 years ago, that we actually wanted to audit the contents of it, and that it mattered to the intermediaries that it was flowing through, that they could actually look at it and even verify the signature on the process, because that there was an audit requirement. Not that they needed to produce it or really consume it, but that there was a problem in the middle. And so suddenly we discovered we needed a standard format. And I think that we are essentially, that's the difference between the multitude of proprietary verticals that have done attestations and what we're trying to do, is that we've recognized that we have other devices that need to interact with those statements, at least to record them for the purposes of the lawsuit later on. Okay? And because seriously, because the device said it would do X and it didn't do X, and whose fault is it? Who said it would do what, right? So I think that's the important part. And so even if we wind up with 6 different formats, because there's 6 different verticals we're working into, the semantics will be the same, and we'll actually have 6 documents that says there's 6 formats, and that kind of sucks, but that may be the reality. So that's where I'm kind of at, and why we need interoperability. And I want to further suggest that even if that wasn't an issue, to Alyssa's point, there are manufacturers, I suspect, that are big enough that having a standard would actually keep them on the same page, right? And they need it simply so that they can actually do something across the board and convince their business units that they actually have to play along. And I suspect that that's an unspoken requirement in some places.
Thank you.
Yeah, Max Pella, Cable Labs. To the point of where the interoperability is actually needed. There's of course many type of examples. Just want to bring one from our industry. Many companies actually, they're trying to secure more access to their network, and with the number of many different devices, and not say just IoT, just devices. Having a mechanism that is actually interoperable across different vendors and that we can leverage to say, I put you in this particular subnet or this other in your Wi-Fi because this is more trusted and this other one is not, actually is very useful. And I think that it's going to be leveraged as soon as is available. So, to the point that I think is something that is going to be very used.
Very quickly, so we can get to the real open money.
Yeah, clarify whether your interoperability is interoperability to a relying party or if you care about interoperability to an attestation server.
You assume that there's an attestation server. Yes.
Got it. And could I ask the AV folks to help us? We shoved the HDMI cable back in, but the Chromebook is not back. Well, so Lawrence, you're up next. So the next portion of
It's the IT guy.
So next up, kind of on the agenda was a conversation about a draft called EAT, which is a token-like format to encode some of these attestations, and this could potentially be a starting point for representing to be a format for some of the things we've talked about.
Shall I get my laptop and try it? I mean, I really want the slides.
Yes.
I can't really do this
tricky without the slides. If you pull it out, I can get my laptop.
So while we're suffering the technical difficulties, I will abuse some AD privilege and ask Dave about his attestation service, because I think I'm still kind of confused about the architecture that you're proposing. And I guess I don't understand if the attestation service is supposed to be closer to the manufacturer or to be part of like the verifier, so that the verifier and the relying party are different entities.
I'm going to give you the same answer as Eric Nordmark. There's potentially a manufacturer of the security chip that's relevant, maybe at the beginning, but certainly at the end of the day, there's whoever owns the policy for whether that device is healthy or not. Okay, it may or may not be the device manufacturer, it may be the owner, but somebody is the owner of that particular device that is in charge of the policy for whether that thing is healthy. That's who runs the attestation survey.
Okay,
I think that's consistent with the same thing that Eric said earlier.
it's not clear to me that the question that has been tried to propose to us is to answer, is this device healthy? Is to say,
Right.
this is a device that can do X. And I think the policy would be at the verifier and we're getting cut off.
All right, sorry. Yeah, we have the slides up. Oh, what just happened? There it is. We have presentation mode. All right, we're going to press forward. We apologize.
All
Let
right,
Lawrence get through his content and we'll open the mic back up.
I'm going to introduce myself. So I was at Qualcomm for many years, recently left. While I was at Qualcomm, I developed basically entity attestation token. It is in a commercial Qualcomm product today. And I'll kind of go into some of the background for like, you know, where that was coming from and what we did there. So this is the original version of the slide. It's the three parties, definitely agreed on the three parties. I'm showing entity manufacturer at the top there. This should be looked at as more of an example or a model than saying it only can be the entity manufacturer. Actually, the vision here with EAT was that might be combinations of and I'll show you some examples, combinations of things. There could even be delegation or attestation server. Coming from a chip vendor point of view, it was interesting from a chip vendor. I think it's interesting to note that Intel, for example, operates a service there with EPID. Qualcomm actually operates a service for this thing, and Google actually operates a service for this. They're not a entity manufacturer, but they do care for Android. So the point here is there's these three parties, the entity, the device, and the point of entity here is that it is quite open-ended. It could be a device, it could be a subsystem of device, it could be a car or a part of a car or a part of a car. Trying to be very open-ended on that. Relying party is somebody that cares about what that device's characteristics are. There has to be key material going from the third party at the top there that goes into the entity for the system to work. The relying party has to get some key material from the third party up at the top there to be able to verify the signatures. But I'm purposely open about what that crypto is because there's a lot of different possibilities there. Symmetric keys, asymmetric, based on X509, or based on something like ECDAA if you're going to do privacy. Now, given that whole model, the target for EAT, we actually brought EAT as a draft to, we actually had a BOF in Montreal as well. Actually, RATS and EAT arrived at Montreal at the same time. We chose not to have an EAT BOF here. We're kind of combining that. So, but they kind of came to this in parallel. EAT coming from the mobile world, biometric authentication world, and payments world. Very different world from the kind of TCG, TPM, and network and routing world. So anyway, the interesting part that was proposed for standardization in EAT is that particular token there, the green box I'm showing right there. And in particularly the claims, the semantics of the claims in that box, or the things, and I think that's lining up to some degree with where people say there's interest in achieving interoperability. The key material exchange on that seems difficult to me to standardize at this point. It seems like there's too much variation going on, too many options, and some symmetric, some asymmetric, or ECDA. There's many options there, and the idea was that those could be standardized, maybe in a second phase further down the line when there's more understanding about what attestation is. So I got to EAT by looking at FIDO, and the proliferation of attestation formats in FIDO. It was really disappointing to me because it's blowing up the interoperability of FIDO. The sort of the last one that got me was the, moving on to Android-based attestation. We had a couple of standards in the FIDO Alliance, then they kept adding them. So FIDO has pluggable attestation, so people were plugging things into it. And there's a couple of interesting points about that in terms of the FIDO case here. One, it has pluggable attestation, so it's got a protocol already with a place to plug in an attestation. So that solves, in the FIDO environment, that solves the transport problem. It's already there. FIDO also has a metadata service that acts as a trusted introducer between the phone manufacturer or the authenticator manufacturer and the relying party, which might be the enterprise or the bank or something like that. So, so EAT is, one thought is that EAT could become the standard or a standard, another standard for attestation in the FIDO use case. In that case, what's going on the phone here or the authenticator side is not necessarily that there's a TPM root of trust. You could do this with Trust Zone, you could do this with SGX, and people do it that way. You could even do it with a secure element. I mean, and other, yeah, there's other cases there. Here's another case of a real deployed attestation service. Android O and key store has a way to attest to a public key that is stored and controlled by a biometric authentication in the Android key store. And in this case, Google operates a server that can do these verifications. Google also supplies key material for this whole loop. So now I'm looking at here's one world, the Android world. Hundreds of millions of devices deployed here using attestation in a format. We've had some interaction with the Google guys, and they've expressed some interest, but I won't say any more than that. So here's another example, and what's important to look at here is the lower right. The output there is a payment risk engine. There's a company called 41st Parameter because they have 41 parameters that go into the risk engine. Was bought by Experian recently. They probably are up to more, but those risk parameters are browser strings, all kinds of really low quality unsecured stuff. So the idea here is to get them better data. Here's a case about a home appliance. Let's say Maytag has a web service that their washing machines connect to. They do not want some other manufacturer's washing machines connecting and using their service. So they need to know those are Maytag washing machines. So and here it's probably a really low security thing because it's just about some washing machine stuff. I mean, sure, Maytag thinks it's important, but it's not a $10,000 payment. So you're really just trying to keep track of manufacturers. And in this case, I don't think you need, I mean, the only software running on the device is from Maytag, so you don't need a fancy root of trust. You don't even need to partition the attestation signing keys from the rest of the software. In IoT, when you onboard an IoT device into an IoT management system, you need to know something about where that device came from. IoT devices, in this case, I'm showing some interesting key material and key management stuff here. So all the IoT manufacturer does is put in a 256-bit seed that's used to gen a public key pair on the device and in the infrastructure. So it's used both places. And then the IoT management system can go back to the IoT manufacturer and say, did this public key come from an IoT device you made? So no X509. All you're doing is putting 256 bits seed in the device. FIDO also operates with security keys like little USB or NFC connected things. Here, they probably run on a secure element. So now there's another kind of use case here where you're looking at the implementation is all on a secure element. So there's not really even a partition of that device. It's all in a secure element. So the primary goal with at least my thinking about EAT was the things we're going to standardize on are the device identity. I mean, you got 1 million devices, you got 1 million serial numbers. We want to know which is which. 2, we want to do measurement. So that's measuring the software, the state of the software on the device. That could be one time at boot or runtime, once a day. We want to know boot, debug, and configuration states. Like I measured twice, it's important. So geographic location, like GPS coordinates, inventory of device hardware and device software, and then a really important one is a public key that's created on the device, or key pair that's created on the device, and you transmit the public key. Basically believe the claims should be generally applicable, so not specific to TPMs, trust zone, SGX, secure element, should work on all of those sorts of things, and also not any particular security level. So the idea was to use basically CWT, which is COSE, that gives you the algorithm, the ability to express different algorithms and all the structuring you need for signing something. Identifying keys, carrying certificates, all of that. So that's kind of the outside part. The idea was also to use CBOR claims because they're very flexible. You can express lots of different data with them. We want to standardize a basic set of claims, but we want to be very flexible about the claims. I think privacy is an interesting point here because privacy is affected both in the key material and with the claims. ECDAA gives you privacy around the signing system, but then you also have to be careful about the privacy of the claims. When we implemented this at Qualcomm with Android, we did it with paying attention to the Android privileges. So when you requested a token, it wouldn't put stuff in there you didn't have privilege for as an app. This is just a simple example. I don't think I won't spend too much time on it, but you can see it's pretty small. Basic attestation using CBOR and COSE is about 130 bytes for that particular one. I probably don't need to say too much more about this for this group. Yeah, okay, and that was the privacy part, which I already have spoken to. So that I believe is it. All right, well, thank you.
So questions for Lawrence before we turn to open mic? Questions for Lawrence first? If there are none, we can go open mic.
No.
Okay. Okay.
Okay.
Thank you, Lawrence. I'm opening the floor.
Thank you. I just was standing here waiting for the open mic, and I am Carsten Bormann. Thank you. So I just wanted to make one minor point, because we have been looking at slideware for 90 minutes now. And people who are making slides, of course, try to make the simplest possible picture. And so in these slides, you usually see one server doing something. And the reality is that is not the reality. So even Lawrence's slides had some cases where you had 2 servers. And in general, you have to expect that a serious attestation system has a few entities that will cooperate in creating the attestation we actually need. So it's that's actually one place where we need the interoperability to make that happen so we can have multi-stakeholder systems.
Thank you. Dave Saylor, I didn't understand your last part of the comment, so be prepared to get back up here again in case you were answering the question I'm going to ask Karsten. One of the things that I noticed in the last presentation was that it also had a line that I didn't talk about in the problem statement, and I wanted to say what that line was and ask whether people care about interoperability there. So when I got up before, I said there's a line that goes from the device to the routing party, and there's a line that goes from the device to the server at the top, whatever it is. Okay. There was also the line that was showed in those diagrams that went from the relying party to the server at the top. Okay, and so I wanted to ask about that line, or maybe comment on that line, and say, going back to Alyssa's question, is interoperability needed there? What's the trust model? Is the assumption that the relying party trusts the attestation server in this? Because what I got out of the last presentation was the implicit answer. Do we care about interoperability there? The presenter's answer was no. And so I will ask the rest of the room. Do people care about interoperability? In this case, it would be line number 2, okay? Because I've heard a lot of people say, I want interoperability for line number 1. I haven't heard anybody have a well-articulated argument for why they want interoperability between line number 3. But line number 2, I haven't heard anybody comment on at all. And so when we ask, other than the implicit no that was in the EAT presentation, do people care about interoperability on line number 2? Or is the scope of this really, we all agree on line number 1, so let's do what we agree on?
Well, thank you for asking me that question. That's why we just drew this diagram.
Right. I actually came up to say something else, but I'll see if I can. I think like experience from like other trusted third-party systems in identity space. You know, it's not initially important to have interoperability other than at 2. That's what you need, right? At 2. That line number 2, that's where you need interoperability from the start, right? Well, I sort of see line number 1 as where the vendors sort of existing solutions sort of live today. All right. Never mind. I came actually say something completely different about privacy. In a couple of the slides, I've seen lines along the line, statements along the line. So we can deal with privacy by just asking the user. By getting consent. And I want to make a note of the fact that consent is a lot more difficult, especially in legal regimes in the EU. We're talking about free and informed consent. So it's not actually always applicable to ask the user for permission, especially if the user can't say no. So, when you write privacy consideration sections for stuff like this, I don't think it's okay to just sort of point to some sort of imagined consent mechanism, and I use that as a cop-out. You have to be a little bit more careful in that.
Thank you. And again, the chairs are not suggesting, by the way, that this is the architecture. We have just heard nodes tossed out.
Done.
So we put the nodes up, we put lines between them so they have numbers, so it might be easier to facilitate the conversation and get a better sense of where we're talking about the interop.
So we were talking about lines and how important they are, and these are the core lines that are not about the things above, I think. So the relying party is relying on something. It probably can be constrained node or something. So basically incapable of doing hard work. So there's the attestation server. I guess probably this is a verification server meant here. And so the verification server and the device both, or service, and the device both have something in them, the root of trust that you put trust on. And then there's something else out in the world there you put also trust in. That there's some chaining into the roots, into some claims, into some values the attestation server consumes. So I think it's important to say there are multiple paths here that we want to actually talk about right now, I think, and they are not in this picture.
So can you quickly summarize which boxes are missing?
That's a certificate authority, for example, and there are root of trusts, and they have typically a root of trust is endorsed. I will take up on that.
Yeah. The reason why we put this up was there were a lot of questions to scoping the problem. The problem underlying here is where do we want to put the focus vis-a-vis the interoperability, which is why we put this diagram up, just to get that clarification.
All right, so I do think interoperability on line 2 would be a really good thing. But from what I know about some of the systems I've seen deployed, it's going to be really difficult to do that. It actually has, what happens on line 2 has some relation to what to what happens on line 3. How do you identify the keys? What sorts of keys are there? You know, and I've named symmetric. There's systems that are using symmetric keys for attestation. Not pretty, but it's doable. There are systems that use X509 in a standard kind of way. There's systems that use public key in a non-standard kind of way. I've seen those. And then there's things like ECDAA, which is today in Intel EPIT. So it seemed pretty difficult to try to tackle that problem at the same time. So I thought tackling number 1 would be the right thing to do. So I think it is important, but it seems a really difficult thing to tackle. Then the other thing on privacy, to respond, is that I think privacy varies tremendously by use case. Like on an Android system where you have a device that talks to hundreds of relying parties, preventing tracking on those relying parties is critical privacy problem, and it works in a particular way. For a light bulb, it's really different. If you're using a banking app, you've already signed a privacy agreement with your bank, so they already know a bunch of stuff. So that's a different case. So you've got to deal with all of those, and our job with privacy would be to come up with some frame up of how you deal with all those varying use cases.
And Max Cabolad, coming to these lines, ideally you want to have a standard format that 1 and 2 and 3 are all standard, right? I can see definitely line number 2 being possibly not there, and having device and attestation server doing their protocol and then disclosing only what the attestation server actually sends back. In general, I would say that for interoperability purposes, I would say it would be useful to have that also for implementations purposes, in the sense that when you're implementing the software, etc., you want to be sure that the format is standardized. So having that at least 3 and 1 to be standardized, I would say it would be useful.
So sorry, I want to make sure I recap. So you're saying you think 2 is useful?
All three might be useful, right? Depending on your architecture. Some architecture have this kind of thing.
All right.
But I can easily say that from my past experience, probably 3 and 1 are the most important one to standardize. 2 would be useful, but it can come later.
Okay, thank you. And just a reminder to everyone, we have about 15 minutes.
Dave Taylor. So I got the impression that different people have different opinions as to what line 2 might be. And I started off this discussion when I came up to the night before by not having line 2. So I agree with this comment that said, if you had designed a system that the attestation server gives you back something that concludes all of the information and the device presents it across line number 1, then 2 may not be necessary in there. And I think Max said the same thing when he was up here. And so that's how I started off my thinking. And then this other line says, when would you do this? Okay. And that's where I think that that one possible answer, and this may be completely different from the case where somebody was asking, I don't know if that's a verification server or what, which I think was Hinksploit. But one case for line 2 might be, because we talked about privacy, that says, well, if I get back from the attestation server a bunch of stuff, do I give that same stuff to every relying party? Answer, probably not. I want to give different things to different people. So I either got to get a whole bunch of different things back from the attestation server, or I get back one thing that contains no information. I tell the relying party, hey, use line 2 to go and ask it yourself, and it's the attestation server's job, and it's the device's job to figure out what that relying party is able to get. Okay, that is a potential use case for a line number 2. Okay, so I wanted to state that as I don't know if that's what people are thinking, but I have the impression that different people are thinking different things. Okay, almost certainly. But that is a case for maybe a line 2 being important, but I still think from what I've heard so far, I've heard the strongest arguments for interop at line number 1, and a lot of fuzziness, and people aren't quite sure as to what line 2 and line 3 actually are, or whether it needs interoperability.
Yeah, we certainly are hearing the same thing. On 1 and 2 and 3, there's a lot of questions to what the use cases and the workflow are.
Yeah, Ben Kadek. So I've been thinking a little bit more, and perhaps I can sort of abstract the idea is that a device has an owner, that owns the device, and has talked to the manufacturer or the vendor at some point, and maybe does provisioning. And then the attestation server could be thought of as also controlled by the owner of the device, and as an engine that applies policy, the policy being determined by the owner. And so potentially this attestation server could be accepting a lot of information from the device, applying policy about who is allowed to receive what information. Potentially it could be condensing down some of that information, produce a smaller subset for output to different relying parties. I'm getting nods from Dave, so this is good. Okay. And yeah, I think we've got agreement about line 1 here, and we may end up having to just go with that.
Thanks, Ben.
Because Norman, this figure is wrong on so many levels, I don't know where to start. So the first problem is, what do the lines actually mean? Does it mean A communicates with B? Does it mean A knows about B? A has a trust relationship with
Negative. Because, no. So all we meant was this is not an architecture. We
Yes.
felt like coming out of the problem statement, one of the key issues was, where do we need interoperability? So what the line and the number really is intended to talk about is, do we need to work on interop between, if in the case of device, in the case of 1, it's device and relying party. In the case of 2, it's relying party and attestation server. In the case of 3, it's attestation server and device. And there's a whole separate conversation if we say we want interop, what does that mean? Interop at what level, and et cetera.
Yeah, so the short answer is all these things, whatever they are, sign something. And so you need at least the capability to actually interpret that signature. You either have it yourself or you delegate it to somebody else. And that's the second problem with the picture. It has one box it has two layers. It has a kettle layer and a pet layer. So the kettle layer is the devices and the relying parties. You have lots of these. And then you have these powerful, closely guarded servers down there. And the problem is that the kettle actually need to talk to servers they trust. And the device and the relying party are in different security domains. So it's absolutely impossible to ever have this situation here. That doesn't work. So you can always include some of the pet functionality in some of the kettles. So have a relying party that also happens to understand the entire world and knows all the trust relationships and so on. But in reality, you need more than 3 boxes. And then the lines also start to make sense. And whether the pets actually need to talk to each other, that's another interesting question. But really the interoperability is about being able to exchange information between several instances here, and not trying to categorize this by what role do we give this instance in this picture, because this picture doesn't mean anything.
Okay, thanks.
Kathleen Moriarty. I think the claims work seems like an interesting starting point from the EAT, right? Because it's well-defined. They've had implementation experience. They played with it. They figured out, this is important. And one of the nice things about if this does become a working group, you can expand from there, right? So what makes sense after that when there's more implementation experience? So just my 2 cents is that might be a really nice starting point. It's well-defined, there's experience, and then grow from there.
Eric, not Mark. Yeah, I would agree with that. So I think that in terms of what, in the bigger picture, right, I think that we would want to be able to provide here something where there's a standard-based or standard set of APIs that are needed to go after the use cases that we think are important, right? Which might include all of these 3, right? But we don't have to start doing that. Based on the discussion I hear, it might be that, yeah, people don't necessarily understand what these things actually do, nor the information that flows over these 3 lines. So that might be another thing that a working group could do, is actually say, pick a bunch of use cases and draw this thing and actually show what information actually flows and the trust relationships or whatever, right? It might be use cases, for instance, responding to Karsten, where the relying party and the device are actually under the same ownership, right? That might be interesting. And you can do different things in that case, as opposed to, more ad hoc relationships. So I think that if you could start with the sort of EAT piece, defining that format, and then in parallel go and work through use cases and actually draw a bit more detail about information flow and trust relationships, we might be able to get a better handle of this stuff going forward and see what are the next set of things to go after.
Hi, Elliot again. I think I'm mostly agreeing with with what Eric said, but I got up here because Dave seemed confused about line number 3 and whether there needed to be Okay, well, you said you indicated that there was some fuzziness about what line number 3 meant, what the use case was for line number 3. And maybe it was my own confusion as to what those components are, because this is a pretty simple diagram, to be fair. But I want to just state outright a clear use case as to why there needs to be interoperability there and what I think those things are. So the device is the device. I think we can settle on that part. Very good. Good job on that one. The attestation server is the thing that is evaluating the claims. And in my use case, that thing is where I see need for it. It's an enterprise element in which it is attempting to determine whether the device is safe to allow onto the network. Okay, so the device and the attestation server are at least likely to be in the same domain. Not 100% sure, right? Right, but let's say. And in that case, the notion that there would be, what does it mean for there not to be interoperability? That would mean that for every single device type, there would need to be an attestation server. And if I propose this to my enterprise customers, they'd come after me with a hatchet.
Okay, in the interest of time, we're going to cut the line at Ben, so we can ask the questions.
So here's a different version of what those boxes and lines mean. So the device is a chip made by Qualcomm or an Intel or Infineon. The attestation server is a service offered by the chip maker. And line 3 is an internal chip manufacturing step. So, and then the relying party is maybe a bank that's actually wanting to know that this transaction that they're processing originated in a very secure part of the chip. So the chip vendor is offering an open attestation service to thousands and thousands of relying parties. And a similar view in this is Android and Google with its service, where line 3 is, or the attestation server is operated by Google. Line 3 is Google supplying buckets of keys to phone vendors. And line 2 is, again, like banks or enterprises asking Google what they think of this device. Then I also wanted to comment, Ben used the word owner. To me, this is all about manufacturers of equipment and software, that really the owner of the device, in terms of like, this is Lawrence's phone, or that phone belongs to Marriott Hotels, or so that really didn't factor into this very much at all. For me, ownership was not a thing. So.
We would just ask for
time check. We've got to.
I'm rushing. So this is Hank from the floor again. So I think the discrepancy between Elliot's use case and Lauren's use case shows the scope of the thing Carsten says. how useful these lines can be interpreted is hard. So yes, use cases will define with a good understanding of what actually will flow in these lines, and when the assertions are of interest to be secured, or go they internationally, or just are the relying party and verifier integrated? Isn't there actually a line, because they're the same system component? And with respect to what Kathleen said, we also have another, we have a reference protocol implemented, because Yang is very popular, and challenge response remote attestation with nonces is basically the old school way of doing it. So there is a draft in the REDS scope that is implementing exactly that already. So there's something else to look at. It's not just only a data model, but actually it's Yang, so it's a model data model. But there's something else to look at that is not just only a format. That's one thing to say.
And Koenig again, I just wanted to share a little bit of my thoughts and sort of, we have this new diagram that you created during the meeting and put up, which is great. Thank you for doing that. And then we had the other diagram that was the super complicated diagram that we saw during the prepared talks. And if I was sort of thinking about how I might have mapped the one to the other, I think, the original sense I had in mind when I was looking at the slides in advance and talking to the proponents, it seems like that case was mostly when the attestation server was just collapsed into the same box as a device. And hopefully that helps people understand sort of how these things map to each other.
Okay, so we're almost out of time. When we opened this, we said that we wanted to explore kind of the area and kind of to move forward. We need better answers to those questions we have kind of popped up there. So kind of Nancy, kind of correct me here where you disagree. To the question of do we think we sufficiently understand what we're working on, I think there is significant ambiguity kind of left. Some of the questions related to is the problem tractable? Since we can't answer number one, we're not kind of there yet. We heard a couple folks come to the mic to say, hey, they're really interested in their work and they want to contribute and they saw all sorts of kind of applications. So that's kind of nice and exciting, which seems to suggest, there's interest in doing this, but there really is some problems related to scope. So more conversation is necessary. And we would point you to the draft. There is draft. I was going to say the charter language. So there is kind of a lot more description, perhaps kind of framing about what is on deck and what might be the potential work in that kind of charter text. That's a place to provide feedback, as would be kind of responding to some of the presentations and letting your use cases be known on the mailing list. That would be exceedingly helpful moving forward. Other things, Nancy?
Yeah, so to progress this, I will not touch it, sorry. So, we heard that there is interest. We heard acknowledgement that there is a problem or a set of problems. I think a lot of the ambiguity is how do we scope it to something that we can succeed as an initial. And then I like Kathleen's suggestion is we need to start somewhere and then we can grow it from there. So would really encourage everybody to participate in the mail, so that we can shape it better, start with the charter. There's a couple drafts too. Ask the questions, provide the feedback so that we can progress it to something that can be meaningful for the group. Okay? Ben?
Ben, do you have a final word on
Yeah.
that?
Thank you for running the BOF.
All right, in that case, thanks everyone. I think there's cookies.
Or more? Well, if you can at least summarize whatever you captured and
about how.
okay. Yeah, if you can, yeah. If anybody, blue sheets, did everybody sign blue sheets? Yeah, I have to stay here, so, thanks. Well, what we said, like,